All right, so remember that this test is the graphing utility test. It's the Desmos test, right? So a lot of these things you can lean on Desmos to help you out. Right? So to me, this is an easier test than the first one. Quite a bit easier, as long as you just are familiar with how to use Desmos. That's the catch. Some of these you can't really use Desmos directly, but you can check your work at the very least using it. Right? So let's talk about one like this. This is a review problem from Unit 3. That's all this is. So we want to write a function in this form. What do we call that form?
Oh, that's
Vertex form. Very good. Okay. That represents the graph below, right? So like any of the forms of the quadratic functions, we just need to be able to know what the numbers are, the parameters, a, h, and k. So what are they? What's a?
A is 5.
Good. How'd you get that? Try it. Almost. Count more carefully. 4.
4, yeah.
Okay, good. How'd you get that?
The actual function graph, what are the amp graph is, what is it, square root?
It's squared.
Yeah, squared. And it's supposed to go over 1, up 1.
Good.
Over 1, up 4.
Very good. So normally we'd go over 1 and up 1, so the height would be 1, right? But this time, we're going up a total of 4, right? So what are we multiplying by to make that happen? So 1 times a, whatever that is, has to equal 4. Well, we stretched it by 4, didn't we? We multiplied by 4. So we know a equals 4. That's the hard part. H and K are super easy. What are H and K?
-6 and -5.
-6 and... No. Hang on. H and K. Think what it, in vertex form, think what H and K are.
I don't know.
Okay, now think. We only spent about, it seems like about 9 months on this. So I want you to, you got to think a little harder than you are for a second here. What is it going to be? What did it say? -5, or -6 and 4. Good, right? Because those are the coordinates of the vertex, right? That's HK. And when we first talked about it, we always think about it, H and K as the coordinates of the vertex, but what did it mean in terms of Unit 3 when we first started off? Just to kind of remind you how this works. That's how we get from our normal parent graph, whose vertex is there at the origin. It's how we get it to there, because those are just the horizontal and vertical translations, really, isn't it? Right? We're translating it horizontally by -6, so left 6, vertically by +4, so up 4, and that moves our vertex from the origin up to its final location, right? So we got all those values. All we have to do is plug them in, and we're done. So we end up with f of x equals a, which is 4, times x minus negative, which is plus 6 squared, plus k, which is 4. So there's our answer. Okay? No big deal, right? So that's what, when we're trying to, once again, Unit 3 review, they're going to give us a parabola, and we got to turn this into vertex form, which is the most convenient one, right? Okay? How about something like that? What form do they want us to put that in? Colton, what form do they want us to put this one in? What is that?
Factor.
No, that's not factored. What is that?
Standard.
Standard. There you go. So standard form where the parameters are A, B, and C. So our goal is to be able to plug those values in, maybe, right? But the problem with this is, you might remember, that we can't really, there is no easy way for us to look at a graph and determine what all those are, right? We can determine what A is. That's pretty simple, right? But the other ones are a little bit tougher. Okay, so what might we do? What's our strategy? And you got it, we're getting to a point in math, and I've said this a bunch of times, where you got to kind of slow down a little bit and think about the strategy before you jump in. I'll give you a hint. This is almost the last problem. It's exactly, just with the one extra step. Yeah, minus h, there you go, good. So we're gonna do this the same way we did the last one, because it's easy to do, right? We can easily look at the graph and determine what are the values of a, h, and k, that's simple. So it's really a piece of cake to put it into vertex form, and then all we have to do, when we have it in vertex form, is convert that to standard form. Remember, standard form is the same thing, that's the simplified form. Standard form really just means simplified, so we're just gonna follow PEMDAS, right? Okay, so this time, what is the value of A? I'll give you a second to look at this, stare at this a little bit, come to an answer. Okay, I'm going to call it. Don't say it out loud, I'm going to call it. So what's the value of A? You got it? Okay, what do you think? You got cold? Tell me.
All right, -3.
-3 it is.
Nice.
And let's think why that is. Good job. Let's think why that is, because normally we would go over 1 and up 1, but this time we're not. This time we're going over 1 and we're going up -3, so down 3, right? So what do we multiply by? -3. Right? So we get, right away, we get A equals -3. What about H and K?
2.
-2, you mean? And -3, okay? And then we'll just plug that stuff in. So there's our first step, right? So we end up with f of x equals -3 times x minus -2 is x plus 2 squared, plus -3 is just -3. So we got it into vertex form. Now we just have to follow our order of operations, right, to get that. Oh, I can't get to it. Anyway, so we're gonna follow our order of operations. Can we do anything inside the parentheses? No, x plus 2, those aren't like terms, so we don't do anything there. Exponents. Yeah, there is an exponent. Okay, so let's think about what are we gonna do if we have x plus 2 squared. That's what we gotta deal with the exponent. We have something which is x plus 2 being squared.
You're gonna do that 2 times.
So we could multiply it by itself and go the long route. Just multiply it out and collect like terms and simplify. Or we could use our pattern. What's our pattern? Ah, there you go, good. So first term squared plus 2 times the first times the second plus the second term squared, right? So it just equals x squared plus 4x plus 4, right? So there's first step, right? We squared out x plus 2. Okay, now what? What's the next step? We did exponents. Okay, but how? What do we have to do? I've got this -3 out in front of the parentheses. What's that mean? It's, yeah, simplify by, but what's the next step? We did exponents, now what do we do? Not divide. Multiply. Right, I've got this -3 out in front of the quantity, and that means it's being multiplied, right? So we're just going to distribute the -3 all the way through. So that gives us -3x squared minus 12x minus 12 minus 3, and then the last step's a pretty easy one. What's that? Yeah. Add, subtract, so we combine like terms. And so we finally get negative 3x squared minus 12x, and minus 12 minus 3 is minus 15, right? There it is. There's our answer. Okay? Okay, what about these? Now, we have Desmos available. So on the other test, these are a little tougher, right? You gotta substitute, solve a quadratic equation, plug the solutions into the substitution equation to find the other variable. There's a few steps. But with Desmos, this is pretty simple. What do we do? Come on now, what do I do? You've done this. Yeah, this is pretty simple, right? We're just gonna write those two equations.
Minus 38.
Okay, so there we go. What are we looking for? I graphed the equations like you told me. We want intersections. Good. Okay, so all I got to do, remember, in Desmos, I'm just going to click on either one of these graphs, and it's going to give me all the important points. It's going to highlight them in gray. So we don't want that one. That one's the vertex. We don't care about that in this problem, but we do want that intersection and that intersection. And so it asks us to round the solutions to 2 decimal places, I believe, right? Didn't it say that? Yeah, rounded the, 1 decimal place, rounded to the nearest tenth. So we would just enter both of those ordered pairs with the numbers rounded to the nearest tenth. Okay? We okay with that?
Sure.
Okay. Take a picture. What about this? What do you think? Same thing, right?
Yep.
Okay, so there they are. They're both graphed. What do you notice about those graphs if I zoom out? They're parallel, so what's that mean? No solutions. Okay. Okay, we good?
Yeah.
Hey, I might just make a little comment. I think sometimes if you get, I think it helps a lot to be like turned around in your desk, so you're facing the front. Here's a great strategy when you're going to college. I'm just going to tell you how math is going to go. Right? Almost all of you are going to have to take a math class. Here's your goal when you're taking math classes, from this point forward. I mean, we're starting to get into stuff now that's, math 95 plus, so we're getting into kind of the more college level stuff, which is the last part of this year and all of next year, and beyond that in college. So here's what you got to do in math. You have to just get to a point where you can get it in class. If you can get to a point where you can quote unquote get it in class, and you might say, okay, I see what's going on, then you can always recreate that. But it's very difficult to get to that point if you don't get there in class. That's fine. Yeah, can you do that, Stuart? You bet. Okay, so you got to get there. That's your goal, right? All right. One like this. Now these So, I know, everybody does, right? They're word problems. It's not very math-like. It's like you're on a roll doing a bunch of math, and then you get a bunch of words in a problem that throws you off your track, right? So, it is. They don't mix well, do they? Okay, so I've been pretty helpful on when people come up to ask help. I've tried to kind of step, but I'm kind of going to get less and less that way. I want you to, now it's time to just step up and get the job done. Think about, but to do these kinds of problems, they do look hard. And when you read through them the first time, it's difficult for anybody to make that connection between the story and the problem, right? So the way you do math problems, rather than trying to, and this is a kind of an more advanced math class, right? So people in here have typically had probably pretty good success in math, and so you tend to try to just brute force your way through these things, by just using brain power. And it works some of the time, but you're going to hit a point in the near future where it doesn't work very well. And it's probably about now-ish, now forward. So the way you have to think about these kinds of problems is you want to be systematic. You want to develop a procedure that you recognize you can apply, and then that makes it a bunch easier, way easier. Because then if you can just fit the procedure to the problem, it's the same way every time. Even though different problems, and on this assignment, these problems do vary a little bit. I mean, they're all going to end up being linear systems, but they're different kinds of linear systems, and the problems look different. But if you can get to a point where you can recognize that there's a pattern for doing these kinds of problems, it makes them really simple going forward, right? And really almost for any kind of a math problem, where do you want to start? And you're going to read through the thing for sure. But what's the first thing you want to do? And before I let you answer that, the other thing I'm going to start to expect, I've been really lax on this, but I've kind of thought about some things over the weekend. I just do things I want to kind of tweak here going towards the end of the year that I think I need to do a little better. One of them is I got to make you do work. I'm getting lazy about not forcing you to do work in your efforts. So from now on, I won't even begin to answer a question on a problem until I see that you got some work going on, right? On these, you just can't do these in your head. You're just wasting time. You're just going to frustrate yourself. You got to go that extra mile and quit being lazy. Get out the notebook and write some stuff down. Organize your thinking now, okay? What's the first thing on a problem like this that we're going to start with? Exactly, what you're trying to find, the unknowns, right? This should be a pretty dumb problem if I said, how much fencing does Chris have? 152 feet. That's not a very hard problem, right? The things that are asked about are the unknowns. So that's where you look. You look at the question. What you're being asked about are the things you're trying to find. Those are going to be the unknowns of the variables, aren't they? 99.9% of the time. So we're going to identify what the variables are. So we'll call X, what is this first one asking about? It wants to know the width of the garden, right? So X we define as width. The other variable, we want to know length, so we'll just call that Y. Okay? And now we can start to try to build, we got two unknowns that we got to find, and so we know we need at least two equations. We got to find some information up here that we can convert from an English sentence into a math sentence. And a math sentence is just an equation, right? So let's look at this. We read through this. It said he'd like to have a perimeter of 152 feet. Well, this is a rectangle, right? And if we look at our variables here, I can draw an easy picture. It's a rectangle, so we'll call that the width and that the length. How do we say that in a math equation? Perimeter, we could summarize this by saying perimeter is 152 feet, right? You always want to try to use the word is in an equation to convert it into math, because is means what in math? Equals, good. So if we say perimeter is 152 feet, we just know that our first equation we're going to come up with, the perimeter has to equal 152. But how do we say perimeter with X's and Y's? What is the perimeter? But what does it mean in terms of this garden? Sum of all the sides, all the distance around it, right? So what is that then? 2x plus 2y equals 152. Got it, right? Okay. Moving on. How about he wants the width of the garden to be 3 times the length. So how do we say that with is? Width. But if he wants the perimeter to be, let's just say with is. Width is 3 times length, right? That's kind of just a short summary using the word is, isn't it? Width is 3 times length. So how do we say that is an equation? Width is, the width is x, right? So width we replace with an x. Is means equals, and 3 times the length is just 3 times y, right? So there's my 2 equations. And this is easy. Now I've got Desmos, right? All I got to do is graph those 2 things and find the intersection. And the intersection is going to be an ordered pair, right? That's an x and a y value. Well, there you go. X and y are my variables. Okay? Make sense? Okay, this is almost painfully easy. I mean, it's almost embarrassingly easy because you have Desmos, right? Now, before we even plug this in Desmos, though, I want to make sure you kind of know what this should look like. If I graph a linear inequality like that, where I've got a less than or equal to instead of an equal sign, what's that going to look like just in general? I don't want to be specific. Hold on now. I've got x's and y's there. So if we were to, let's just do one thing real quick. What if we were to solve this for y? What are the steps we'd go through to solve this one for y? Gotta get the y by itself.
Right.
What would we do?
Put the x's on the other side.
Add 2x, okay, so we'd start off with 5y is less than or equal to 2x, and then divide by 5. Very good. So we get y is less than or equal to 2/5 x, right? So what's that going to be? If I were to graph this, that's a line in slope-intercept form. What's the slope? 2/5. What's the y-intercept? 0, right? It doesn't show up. So we know that's a line that's going to go through the origin. Right, it's going to go through the origin, and the slope is 2/5. So I'm just going to go up 2 and over 5. And so there's my boundary line, right? Okay. Is it solid or dashed? Solid because I'm including the equal sign. And then when we do an inequality, what does it mean if we want all the values of y that are less than the boundary line? Shading below. Right? Get the idea? So then in Desmos, all I'm going to do, and it'll do it for me. In Desmos, it does it for me. All I have to do is just enter those things. And what I should expect to see is 2 solid boundary lines and 2 shaded regions, and I want the part that's going to overlap the overlapping shaded parts, right?
Yeah.
That's the solution. Okay? No baby. You can do that. Okay, factor the expression. So this is just review. This is stuff that comes up from Unit 2. It's a good time to review it because our next unit there's a ton of factoring. Right? So we're going back to that. So you got to make sure you're kind of getting back in that mode. So if we've got f of x equals negative 2x squared plus 4x plus 160, we got to just go back and think about factoring. Think about the steps we go through when we factor something. So what do we always try to do first?
Factor A.
Factor out a greatest common factor. See what's the biggest thing we can undistribute. Okay, so what's the biggest thing we can undistribute there?
Negative 2.
-2, and you even got the sign right. That's good. That's good. We know that when we're factoring out a GCF, we always want to keep the sign of the biggest term, the term that goes with the x squared, or whatever the biggest power of x is. So we're going to undistribute a -2, and then we just need to know what's left over. Okay, well, if I divide each term by -2, that's going to tell me what's left over from each term. Well, what's -2x squared divided by -2? X squared, I heard it, good. What's positive 4x divided by -2? -2x, good. And then positive 160 over -2? Got it, okay? So there's the first step. We factored out the greatest common factor. Now look what we get. Now we get something convenient. We get this other factor in here that's just a quadratic trinomial, like we had in Unit 2, 3 terms. Notice that the value of a inside the brackets is 1, so it makes it easy, right? If this one factors, it's going to be easy to do, right, if it does. Well, do magic numbers exist? Yeah, good. So you got to multiply to negative 80 and add to negative 2. And so we know we're going to, if they multiply to a negative, we're going to get a positive and a negative. And they add to a negative, so the negative one must be bigger. We get negative 10 and positive 8, and we're done. It's completely factored. And now it's in factored. And I didn't even write in the question, I don't even show you this, because this is really just an old reused question. But factored form, remember, is just a times x minus p times x minus q. So a is negative 2, p is 10, and q is negative 8, right? Those are the x-intercepts and the vertical dilation factor, right? Okay? Okay, convert this function to vertex form, right? So now there's a hard way to do this, and we talked about it. We talked about how to do this by completing the square. Then I showed you a much, much easier way to do it, too, if you remember. Because really, if I'm trying to put something, if I want to write a function in vertex form, once again, think about this in terms of a strategy. We've done a lot of this kind of stuff in Unit 4. And what have we always tried to do? Well, we've tried to just figure out what the values of A and H and K are and then plug those numbers in. Like if we're looking at a graph, for example, right? Our goal is to figure out from the graph what are the numbers for A, H, and K and plug them in, and that's our answer. So we can do the same thing here. What's A? 3. You can see this is in the form ax squared plus bx plus c, isn't it? Right? Standard form. So we can see right away that a equals 3. Well, there's one of the 3 done. How do we get the others? Well, I can't, how do I use a, b, and c to calculate h? What's my formula? There you go. Negative b over 2a. So negative b would be negative 24 over 2 times a is 2 times 3. So negative 24 over 6 is what? Negative 4. Perfect. And then how do we get k if we have h? Plug it in. So that's, and the trick for that, remember, is every place I have an x, I'm just going to open up a set of parentheses. Although in Desmos, you could even just define that as f of x and then ask it what f of negative 4 is and it'll tell you, right? You could be tricky. So negative 4 squared is positive 16 times 3. Come on, mental math makes you better at algebra. 48. 24 times negative 4. If you multiply by 4, you just double it twice. So 24 doubled is 48, doubled is, there you go. So we get a negative 96 plus 79. So that's going to give us negative 48 plus 79. What is that, 31? Okay, so then all we have to do is plug those numbers in. We're plugging in 3 for A, we're plugging in negative 4 for H, and we're plugging in 31 for K. And so our answer just looks like 3 times x minus 4, so x plus 4 squared, plus 31. There it is. Okay, last one, and we're done. These. Okay, I want you to notice something. I took pity on you, and for the test, and I gave you 3 points on all of these problems, including the vertex one. So on the homeworks, I'm going to give you a couple tricky ones where you have to come up with the 3rd point on your own. But I'll give you the 3 on all these. So this is, if you remember how to do this, super easy to do. This is a Desmos problem. Right, so on Desmos, exactly, you make the chart, very good, make the table. Okay, so we hit the plus button, we make a table, right? Everybody with me? And we're going to put in all those ordered pairs. So I got 10, negative 23, 2, 1, -8, -59. And then I'm going to come down here, and what do I do? If I want to put this into vertex form, what am I going to enter? Y1, okay, tilde?
Y2.
No.
Shoot.
There's what we're using right there, right? There's the form.
A.
A times the quantity
X minus H.
x1 minus h squared, very good, plus k, and it gives us our answers, right? And it tells you can round everything to 2 decimal places, so you're good. Okay, make sense?
Yep.
All right, you may work. Get questions answered.
Uno, uno,
That's all.
1 minute.